In this video, we will go through caching and content distribution outlined in the course of Switching Systems Architecture. The outline includes introduction of proxies and caches, why we use cache, where to use it, and how we use it, and it concludes with content distribution network. In network, content can be downloaded from the original server or a proxy server which stores the copy of the target content. A proxy server can act as a server that serves the client's request and can also act as a client that forwards requests to the original server if it cannot respond. Proxy can be classified as a configured proxy, which requires client's own configuration to choose its preferred proxy parent, and a transparent proxy, which doesn't require any configuration from client and it is commonly used now. The reason using caching is that faster resources are rare, and the commonly used content should be located in faster resources, because a content accessed by one client might be accessed again in the near future, which is called temporal locality, and other clients may also access the same content, which is called spatial locality. Caching can be implemented in computer memories to achieve temporal locality and spatial locality. Performance is improved by locating recently used and adjacent bytes of computer memory, or DRAM. In network, caching is also implemented to respond to temporal locality and spatial locality. Caching has a lot of benefits, include reduced delay, reduced traffic, and mask unavailable of original server. However, the costs are about implementation configuration, and original server may lose control over its replicas. Where is caching implemented? In client-end system, it is implemented in software, and in network, it is implemented in hardware or a root model. When a router classifies packets, it identifies those are suitable for cache and sends them to a proxy server rather than to the original server. Cooperative caches are also used when one cache doesn't have a suitable copy, and such cooperation effectively increases the capacity of cache and the user population. The next is about how to cache. There are two types of directives: HTML directives, which is limited to HTML objects, and HTTP directives, which is at a low level and most popularly used now. Specifically, HTTP directives have three types: growth directives, predictors, and validation. Growth directives, for example, the command noStore is used to prevent cache, and the command noTransform is used to forbid converting information in cache. Predictors are time information of an object, such as last modified time, expires time, the time when sent by the original server, and the age that how long it spends in cache. There are also some timeliness directives like maxAge, minFresh, and maxStale. The function of predictor is to expire an object. Server can limit the lifetime of an object by sending expires and cache control, like maxAge. For the convenience of validation, each object may have different versions, and the version of a tag can be the last modified time, and can also be a string that distinguishes different versions, which is called e-tag. In validation process, client would check whether a copy is still usable. It would send a GET request with commands like if modified since, if not match, and wait for response from server. If the object is not validated, server would respond with the whole object. Now is about what to cache. Since caching is expensive and requires a lot of memory, it should not cache dynamic content, and cached objects should be useful in the future, which have high cost to refresh. Issues about cache include personalized content and private content are not appropriate for other users. It is overcome by server setting cache control directives. In content distribution network, content providers are CDN customers. In routing process, it uses a map to determine the best CDN server. We can conclude that switches are more involved in content supply. So that's it. Thank you.
Created using Powtoon.